So we are now moving on to special parallelograms. So rhombus, rectangle, square, trapezoids. All the same things we studied last unit and all the same rules. So we're not going to fill all this in, but you should give it a quick look over. So you know all the same stuff is true about a rhombus. So if you have a rhombus in a proof, you can say all those four sides are congruent. So you could say AB congruent to BC, congruent to CD, congruent to DA, which is, I guess, that rule right there. In a rhombus, both pair of opposite angles are congruent. Diagonals bisect each other. Here are the two special rules about our rhombus. So the diagonals of a rhombus are perpendicular. So, you know, for example, what you could say is that AC is perpendicular to BD because the diagonals of a rhombus are perpendicular. And then you can say that perpendicular lines make right angles. And then you can say that all right angles are congruent. So you'd still have to use a lot of those same processes, just with different rules involved. So there's your rhombus rules, your rectangle rules. Here are the two new to a rectangle, or specific to a rectangle. The diagonals of a rectangle are congruent, and a rectangle has four right angles. All right, so you know all right angles are congruent from there. Square, we know, has everything. Angle bisectors, four right angles. Diagonals are perpendicular. So a lot of stuff that we can use for a square. And then a trapezoid. Again, I would take a minute, guys, and look these over. But a trapezoid, we know, in an isosceles trapezoid, I guess I should say, the legs are congruent. So you can say those two are congruent. We know the base angles here and here are congruent. All right, and we also know the diagonals are congruent. So in an isosceles trapezoid, there's also a lot of little things we can prove. So remind yourself of these rules. Maybe go back and take a look at them again. But that's where you're going to start. Now let's do, why don't we do number 2 together? So setting up number 2. We know a couple important things right off the bat. Whoa, that was a bad line. There we go. All right. So our givens, we know CF, perpendicular to FD. That should be a red flag about using right angles. We know that CF is congruent to CE, and we know ABCD is a rhombus. Huge piece of information, because rhombus, if you flip back a page, has a whole ton of rules about it. And we're trying to prove, remember, don't forget to look at what you're trying to prove. We're trying to prove angle 1 is congruent to angle 2. So I shade those in so we have a goal in mind. All right? We know one thing for a fact, that CF and CE is congruent, and we have those other couple of pieces of information. So what I see here, just by looking at this picture, we want to prove these two angles 1 and 2 are congruent. That looks like a really good case for CPCTC, because you see we have a triangle here and a triangle that looks pretty congruent to it right there. So if we can prove these two triangles congruent, we can prove the angles are congruent because of CPCTC. So that becomes our new goal, to prove those two triangles are congruent. And let's go through our list here. Let's go down and look at our givens. Given number 1, CF, perpendicular to FD. CF, perpendicular to FD, that means angle F is a right angle. And we know that because we've been doing this all year. Perpendicular lines make right angles. All right, we've used our first given. Great job. What this tells me, remember, I'm not going to give you a proof that doesn't work. Keep that in mind. It's a really, really good thing to remember. I'm not going to give you a proof that doesn't work. So if you look at this angle right here, angle F, if we reflect it up here and end of this angle, there's a really, really good chance that this angle right here that I just circled is also going to be a right angle. All right, there's a right angle down below. There's probably going to be a right angle up top here. And we think back to our rhombus rules. So we flip back a couple pages. That was actually one of the ones I showed you here. Boom, right there. The diagonals of a rhombus are perpendicular. So you need to still really, really know your rules. So what we can come up with now, we can say that BD is perpendicular to AC because diagonals are perpendicular in a rhombus. Alright, so we're using that rhombus to open up some new rules for us. And since the lines are perpendicular, what does that tell us? It tells us we have a right angle right there. So angle DEC is also a right angle. I almost wrote also. Angle DEC is a right angle. Because, same reason as above, once we know the lines are perpendicular, we know that perpendicular lines make right angles. Alright, so just kind of process of elimination. Since that one angle down here was a right angle, we just wanted to find a way to show that this was a right angle. And now we can tie them together. Since angle F is a right angle and angle DEC is a right angle, we know those two angles must be congruent to each other because all right angles are congruent to each other. All right angles are congruent. Let's take a look back up here. We have two pieces of information. We only have 6 to pick from, right? So we know one of them is what we're trying to prove. So we're trying to prove those two are congruent. So we're not going to be able to use those angles in our proof. If you look at DE and FB, I don't know, one's part of a diagonal, but this is down below here. I don't know if there's anything we can use to prove those two segments congruent. So we look, I don't know, maybe at these angles here. So in a rhombus, the diagonals bisect the angles, but this is not part of our rhombus, so I don't know, let's move on. If you look at this side here, and hopefully you saw that right away, side DC is actually the same exact side in each triangle. They're sharing a side. And hopefully we know exactly what that's called. That is called the reflexive property. So we know DC is congruent to DC because of the reflexive property. And actually we're done. There's our third piece. So what we have is an angle side side proof. Hopefully you remember we can't do that. ASS or SSA is not allowed. But since we have a right angle there, we do have our right triangle HL bonus rule. So I can now prove without a doubt that triangle CED is congruent to triangle CFD because of the right triangle hypotenuse leg postulate. And that was our whole goal, because now that we know those triangles are congruent, remember after the triangle is congruent, then comes CPCTC. And there's our last step. Alright, so really go back and refresh yourself on your parallelogram or your rhombus, rectangle, square, trapezoid rules. And most of the time when you see a proof like this, you'll be using those examples. Alright, so there's this video. We'll move on to the next one. Keep watching these videos if you don't feel sure, guys. You don't need to take the quiz right away. Alright, watch another one, practice a bunch, use my answer key. Make sure you have a good grip on it. Alright, next one.